I am Dr. Prof.Chishty and I am teaching physics to the BSc second year students. My today's topic is cohesive energy and type of the bonding. Now, what is the meaning of the cohesive energy? Cohesive energy means the lowest amount of energy gained to separate the two atoms. So U minimum will be obtained at a distance, interatomic distance, R equal to R0. Now, for example, we can say that whenever there are insulators or the semiconductors, this type of material has the large amount of cohesive energy. While in case of the metals having the electron in sp bond, that possesses very low cohesive energy. So depending upon the strength of the bond or the cohesive energy of the bonds, we can classify the bonds into two main categories. One is known as the primary bonds and another is known as the secondary bonds. Primary bonds means the bonds having the cohesive energy of the range 1 to 10 electron volt. In these types of bond, you may include ionic bond. Then you may include here the covalent bond and metallic bond. Then these are the primary bonds. Now in case of the secondary bonds, the cohesive energy is of the order of 0.01 to 0.05 electron volt per atom. Very low cohesive energy. And this type of bonds are hydrogen bonds or van der Waals bonds. So they possess very low cohesive energy. So let us study about the primary bonds, and in this the first bond is the ionic bond. Ionic bond means when the electron from the one atom get transferred to the another atom. Means actual transfer of the electron take place in case of the ionic bond. Means, for example, sodium having the electronic configuration 281 and the chlorine having the electronic configuration 287, means the sodium will transfer the one electron to the chlorine atom. So chlorine atom will get one electron and sodium will lose one electron. So such type of bond is called as the ionic bond. And in case of the sodium chloride crystal, the bonding will form in this way. There is one chlorine atom, one sodium atom, and there is transfer of the electron from chlorine to sodium. Such type of bonding will form. So what will happen in case of the ionic bonds? The cohesive energy may be from 1 electron volt to 10 electron volt, and these bonds are crystalline solids. These compounds are closely packed atoms or closely packed molecules. They are having the high melting points, high boiling point. They are soluble in water and liquid ammonia, but they are non-soluble in polar liquids. Moreover, these atoms or the molecules are the bad conductor of heat and electricity, but their solutions, if we dissolve, their solutions are the good conductor of the electricity. Now the second type of the primary bonds is covalent bond. Now covalent bond is formed because of the sharing of the electrons. So if an atom is to become octet, then he has to obtain some electrons from the neighboring atom. For example, if I take the case of the germanium atom, germanium has the 4 electrons in the outermost orbit. Its valency is 4. So another germanium atom will share the electrons, 4 electrons of its orbit and they become the stable. Then in the same way, O2, oxygen gas, N2, nitrogen gas, H2, hydrogen gas, chlorine gas, all these are the examples of the covalent bond. Means there is no transfer of electron. In case of the ionic bond, electron is permanent, get transferred, but here electron is not transferring, but the sharing of the electron take place to become octet. Now here take the example of hydrogen gas, H2, means there is a single bond. O2 means double bond. So take the chlorine, example of chlorine. Take the example of diamond, graphite, silicon, germanium. All these are the examples of the covalent bonding. Now, in case of the metallic bonding, we know that in case of the metals, the valence band is completely coinciding with the conduction band. So if an electron is there in the valence band, it is as good as in the conduction band. Means the electrons, a cloud of the electrons are readily available for each and every atom in the crystal. In the metals, every electron, a cloud of the electrons will be available to flow from one place to another place, and this cloud is available for each atom, each molecule of the substance of that metal. So such type of bond is called as the metallic bond. But these types of bond are weaker than the ionic bond. They are having the moderate type of the melting point and the boiling point. Wherever these are the ductile, malleability, high conductivity is there, and these substances are opaque. They are having the high optical reflection. Because of the electron, there is high optical reflection. Therefore, the reflection of the electron will become will be there in case of the metallic bonding. Okay. So all these are known as the primary bonds: ionic bond, covalent bond, and metallic bond. Now come to the secondary bondings or the secondary bonds. In secondary bonding, we are having the two types of bonds. One is known as the hydrogen bondings, hydrogen bond, and another is known as the van der Waals bonds. So in case of the hydrogen bond, there is dipole-dipole attraction, and the cohesive energy is from 0.1 to 0.5 electron volt per atom. And we can see that when in case of the van der Waals bonds, if we study about the van der Waals bonds, it is also known as the dispersive bonding, and the last shell in the van der Waals bond is completely filled, and there is no tendency to gain or lose the electron as in case of the inert gases, helium, neon, argon. All these are gases, the outermost orbit is completely filled, and their cohesive energy is between 0.1 electron volt per atom, and therefore they are having very low melting point and the boiling point. So this is all about the primary and the secondary bond. Thank you.